Question number 1. Momentum has the same unit as. Look at board here. This is the easiest way to get the answer. Sometimes this is the easiest way. For a force acting for a very short period of time. Very short period of time. The product force into time is defined as impulse. Please write this here. For a force acting for a very short period of time, the product force into time is defined as impulse. Write it. Clear? Right. But we know that force is equal to the product mass into acceleration. So mass into acceleration into time means impulse. Please look at board. What is acceleration here? Acceleration is, what's it? Increase in velocity divided by time into time equals impulse. Now what will happen here? This t and this t cancel out. M into v minus u equals impulse. Am I right here? If the object starts to move at rest, then what will happen here? Impulse equals m into v minus u. What is u now? The object starts to move at rest. What is u dear? 0. So this is m into v minus 0. So this is mv. So that is the product mass into velocity is linear momentum. Linear momentum. Got it? So what is the answer for the first question? The momentum has the same units as impulse. Answer is 2. Answer is 3. Just write them all. But it is not saying that object starts to move at rest. So that's the nature of the exam. You have to imagine that some part of the things. Question number 2. The resultant of 6 coplanar forces. Coplanar forces mean all the forces are acting on the same board, same plane. If I take this whiteboard is a plane. All the forces are on the same plane. That's the meaning of coplanar forces. AB, BC, CD, DE, EF. So what is the resultant here? AB, BC, CD, DE, EF. think body mistake here. EF on moment, not general. I think one line is given additionally. A, B, but letters are given, therefore there should not be any upset. A, B, B, C, C, D, D, E, F. So this is polygon theorem of vector addition. When several vectors are represented by the directions and magnitude by the sides of a polygon, right? The resultant is represented by the line joining the starting point and the ending point. So resultant vector is AF. So please draw this figure here. This is the answer for question of this is such a simple thing. Polygon theorem of vector addition. Question number 2. So the resultant vector of all these vectors AF Right. Question number 3. What is the answer for this question? Answer is 3. Question number 3. Read. The figure shows the velocity time graph. The figure shows the velocity time graph for a particle which starts from rest, starts from A with the velocity u, moves along the x direction, according to this graph, the particle will come to A during its motion. This is the velocity time graph. What is the displacement? How do you obtain displacement from a velocity time graph here? Area under the graph. What's the meaning of positive, negative of a velocity time graph here? Positive means object is moving to, let's say object is moving to one direction. If we take velocity into that direction is positive, velocity is into the opposite direction should be negative. So this graph has two sections, a positive section and negative section, right? The positive section, if you get the area under the positive section of the graph, it gives the displacement of the object into the positive direction. For example, listen here. For the question number 3, let's say this is point A. So let's say object is moving to right hand side. So velocity into the right hand side positive. Am I right here? So velocity into the, after sometimes velocity change and it starts to move to the negative direction, to the left hand side. Okay? Let me explain this. What is the initial motion up to t1 here? Velocity increases. Am I right here? Velocity increases. So it's an acceleration. So it travels in the first t1 seconds. It travels with an acceleration. It travels with an acceleration. So initial velocity u, final velocity v. The object travels from A to B. After the end of t1 second, what has happened here? Velocity is going to be reduced, and finally velocity becomes 0. Am I right here? So look at what it travels from. Let me draw the point B here. It travels from A to B with an acceleration for a period of t1 seconds. Velocity increases up to v. Then the velocity decreases and velocity becomes 0 at the time t2. So t2 means this total time duration is t2. Check the graph carefully. t2 is the total time duration. The time taken for the object travel from A to C is t2. A to B t1. That's according to the graph. After that, what has happened here? After that, once the velocity becomes 0 at C, the object starts to move to the opposite direction. What do you think about that time duration here? That time duration is very small. After t2, it travels with another acceleration, but this is a very small time period. This is a very small time period. Check the graph here. Right? It obtains a certain velocity. Let me take it w meter per second, and again it decelerates and comes to rest. So if you check the graph, this is E. If I take this as capital T1 and capital T2, this capital T1, T2, very small time periods. Check the graph here. So it means the object will never come to the point A again. Okay? So it can be explained by drawing a figure like this. There is another method to explain. First, you draw this figure for the question number 3. Draw this figure for question number 3. Then I'll explain this using another method. First, let's try to complete this method. Right, please write. Below the figure, please write. During the first T1 seconds, during the first T1 seconds, during the first T1 seconds, comma, during the first T1 seconds, comma, the object travels with an acceleration during the first T1 seconds, the object travels with an acceleration from A to B, from A to B, next line, next point. After that, next line, next point. After that, it travels with a deceleration. After that, it travels with a deceleration. It travels with a deceleration and comes to rest at capital C. And comes to rest at capital C, at C. Full stop. Then next line, next point. The direction of the velocity is reversed. The direction of the velocity is reversed. The direction of the velocity is reversed at C, and starts to move with an acceleration, and starts to move with an acceleration into the opposite direction, into the opposite direction, into the opposite direction for a period of capital T1 seconds, into the opposite direction, comma, for a period of, into the opposite direction, comma, for a period of capital T1 seconds, capital T1 seconds. Full stop. Next line, next point. After that, the object decelerates, the object decelerates, the object decelerates for a period of capital T 2 seconds, for a period of capital T 2 seconds, for a period of capital T 2 seconds, and comes to rest at capital E, comes to rest at capital E. Okay, dear. Next line, next point. According to the graph, T1 and T2 time durations, according to the graph, T1 and T2 time durations are smaller than, according to the graph, capital T1 and capital T2. Do not change capital symbol. According to the graph, capital T1 and capital T2 time durations are smaller than simple T1 and simple T2 time durations. Simple T1 and simple T2 time durations. Full stop. And also, look at code, and also W meter per second velocity. Look at code and write. W meter per second velocity is smaller than v meter per second velocity, and also w meter per second velocity is smaller than v meter per second velocity. V meter per second velocity. Okay, dear? Therefore, the distance traveled into the right hand side direction. Therefore, the distance traveled into the right hand side direction is smaller than the distance traveled into the left hand side direction. Therefore, the distance traveled into the right hand side direction is bigger than, I'm sorry. Therefore, the distance traveled into the right hand side direction is bigger than the distance traveled into the left hand side direction. Okay? Therefore, the distance traveled into the right hand side direction is bigger than the distance traveled into the left hand side direction. Okay? Therefore, the object does not come back to the point capital A. Therefore, the object does not come back to the point capital A. Therefore, the object does not come back to the point capital A. Okay, dear? Read that description, compare the description with the given figure here. Read the description and compare the description with this figure. Right, now let's come to the graph here. How this story is represented in a velocity time graph. This is time measured in seconds. This is velocity measured in meter per second. So the first thing is this. During the time period 0 to t1, the velocity increases from u meter per second to v meter per second. That's the first thing you should recognize. So object travels within t1 seconds from A to B with the velocity with an constant acceleration. Velocity increases from u to v. Okay, dear? After that, the object decelerates and comes to rest. Am I right? So that time period is t2. The meaning is this is t1 and this is t2. That's the meaning there. That's 0, t1, t2. That's the real meaning. After that, what will happen? After that, the traveling direction is reversed. The traveling direction is reversed. An object travels, if the object travels in right hand side earlier, at C, it starts to travel to the left hand side. It starts to travel to the left hand side and the velocity increases to w meter per second. So here we should say minus w. Minus w means direction is, if the earlier velocity is in right hand side, w meter per second velocity is into left hand side. The direction is opposite. That's the meaning of the minus sign. So this happens for this t1 seconds time period. So this time duration is t1. Then again object decelerates and comes to rest. Right? This time duration is t. So that's what described by the graph. So we have completed graph. So it's okay to give a question from the graph section. Draw this graph also. Draw the graph also. So according to this description, it is confirmed that the statement A is wrong. Am I right? The particle will again come to A during its motion. Capital A is the starting point. Right? So according to the description, particle will not come to the starting point again. But the other method is, what is the area under the graph in the positive section? Area under the graph in the positive side is bigger than the area under the graph in the negative section. It means displacement in right hand side is bigger than displacement into left hand side. For the object to come back to the starting point, displacement in right hand side should be equal to the displacement into the left hand side. Therefore, the object will not come to the starting point again. Clear here? So, without writing so many description, by just looking at the graph, we can say statement A is wrong. I think using the graph is better than writing a description by drawing a figure. So this method consumes a lot of time, but By looking the graph at once, we can say area under the graph in the positive section is bigger than the area under the graph in the negative section. Therefore, displacement in right hand side is bigger than displacement into left hand side. As the displacement in right hand side is not equal to the displacement in the right hand side, the object will not come to the starting point again. Therefore, statement capital A is wrong. Okay, dear? Right. Who wants more time to draw this figure? Draw this graph actually. Right. So please try. Start with area under the graph. Area under the graph in the positive section. Area under the graph in the positive section. Area under the graph in the positive section is not equal. Area under the graph in the positive section is not equal to the area under the graph in the negative section. Is not equal to the area under the graph in the negative section. Negative section. Therefore, the displacement into right hand side direction. Therefore, the displacement into right hand side direction Therefore, the displacement into right hand side direction is not equal to the displacement into left hand side direction is not equal to the displacement into the left hand side direction. Left hand side direction. Therefore, the object does not come back to the starting point capital A. Therefore, the object does not come back to the starting point capital A. Therefore, the object does not come back to the starting point capital A. Right? Your line and right. Therefore, statement capital A is wrong. Therefore, the statement capital A is wrong. Therefore, the statement capital A is wrong. Clear? Then statement capital B. The particle will come to rest at the time t equal t2. T equal t2. Yes. At the time t2 velocity is 0. And t equal t3. At t equal t3 is also velocity 0. Right? t3 means this total time duration. This total time duration t3. Object comes to rest during the time t3. That's correct. Statement B is correct. Leave a line and right. Statement B is correct. By just looking at the graph, you can say at t2 velocity 0, at t3 is also velocity 0. Right? So please write. Statement B is correct. C is wrong. Why? Statement C is wrong. Why? The particle accelerates only the time duration 0 to t1. Because of the word only it is wrong. A to B accelerated, C to D also acceleration. Right? A to B and C to D, there are two acceleration time periods. A to B and C to D. Therefore, statement C is wrong because of the word only. Please stop with that why. There are two acceleration time periods. There are two acceleration acceleration time periods. There are two acceleration time periods within brackets A to B and C to D, A to B and C to D, A to B and C to D. Leave a line and write. Therefore, the statement C is from. Leave a line and write. Therefore, the statement C is from. Read all the things, check whether you can understand. Come on. Read them all. Read them all and check whether you can understand. So finally, what is the answer here? A wrong, B correct, C wrong. So answer is only B is true. So answer is true. I would like you to write like this. Answer is true. Just write exactly like this. Alright. What about the fourth question? In a vernier instrument, 50 vernier parts coincides with 49 main scale parts. If one main scale equals to 0.5 millimeter, the least count of the instrument is. What is the least count equation? There are two equations. What is the best equation for this case? The best equation for this is least count equals length of a main scale division divided by number of divisions on the vernier scale. Length of a main scale division is given as 0.5 millimeter and the number of vernier scale divisions given as 50 vernier parts. 0 divided by 50 0, 5 divided by 50 0, 50 divided by 50 is 1. So 0.01 millimeter is the least count. That's it. To remember this equation here. Length of a main scale division is divided by the number of divisions on the vernier scale. Question number 4, answer is 1. Question number 5. Read. Consider the following statements made about the physical quantities. There are 7 basic physical quantities, correct? Basic mean fundamental. There are 7 basic physical quantities. Question number 5. Statement A is correct. Thermodynamic temperature and luminous intensity are considered as basic quantities. Basics mean fundamental. Correct. Thermodynamic temperature and luminous intensity, basic quantities, fundamental physical quantities. Plane angle is not considered as basic supplementary in SI units. So they use the both words basic and supplementary. That's the difference. Plane angle is considered as supplementary SI unit. It is correct. So even with the word basic, it's okay because the supplementary word is there. As the term supplementary is there, plane angle is considered as the basic supplementary SI unit is correct. But here it is saying not considered. Underline the word not. Underline the word not. Plane angle is not considered as a supplementary SI unit. Even with the word basic, this statement C is wrong because it is saying not considered. Therefore, C is wrong. So, what is the correct answer? Only A and B are true. Answer is true. So, they are very simple questions. Simple, but we must ask this kind of questions because we have completed it. Question number 6. A ball of mass M1 moving with the velocity V. A ball of mass M1 moving with the velocity V undergoes a head-on collision with a ball of mass M2. M2 at rest. After the collision, ball A continues moving in its original direction with half of its original speed. The speed of the ball B after the collision. Shall we draw a figure? So what is this here? This is the law of conservation of linear momentum. Haven't we learned it here? Huh? Question number 6. Write a ball of A of mass M. Look at board here. There are two balls, A and B. A is moving with the velocity of V meter per second. B is at rest. They collide. A and B collide. After the collision, A moves with a certain velocity, B moves with a certain velocity. Draw this figure here. Draw this figure quickly. There is no rotational motion. They are just sliding. They are just sliding, moving with some velocities. Clear? So this is the situation before the collision. This is the situation after the collision. Mass of A is M1, mass of B is M2. A continuous moving in its original direction with half of its original speed. Half of it means V1 is V over. So we want to find what the V2 is. We want to find what the V2 is. Draw the figure here, quick. Draw it. So what should we do next year? We should apply the law of conservation of linear momentum. So please write, let us apply the law of conservation of linear momentum. Let us apply the law of conservation of linear momentum. Let us apply the law of conservation of linear momentum. Right? Then please write please write, let us apply the law of conservation of linear momentum. Then please write, we will linearize the equation. Total linear momentum before the collision equals total linear momentum before the collision equals total linear momentum after the collision. Total linear momentum before the collision equals total linear momentum after the collision. Total linear momentum before the collision means, look at board, m1 into u1 plus m2 into u2. m1 into v1 is the linear momentum after the collision, and m2 into v2, that's it. So we indicate the direction because linear momentum is a vector. So m1 into v plus m2 into initial velocity of the other object is 0. m1 into, after the collision, velocity of A becomes half of its original velocity into m2 into v2. Can you find what the v2 is? Can you obtain an expression for v2? The speed of the ball B after the collision. Right here. So this is m1 v1 plus 0 into 0. This is m1. This is not v1 v. This is m1 v over 2 plus m2 v. So if I take this to this side, m1 v minus m1 v over 2 equals m2 v. Right? So if I take m1v out of a bracket, if I take m1v out of bracket, remaining terms 1 minus half. Am I right here? m1 in m1v into 1, m1v. m1v into half, m1v over 2. That's correct. What is 1 minus 2, dear? So this is equal to m2v. m2v. So what is this 1 minus 2? 1 minus half is half. 1 minus half is half. So m2v2 equals m1v into half. If I take m2 the other side, I get v2 equals m1v, this v2 and this 2. So 2m2. That's it. So which choice is correct? Is it 5? Answer is 5. Question number 7. A force of simple F Newton is applied on an object as shown in the following figure. How much work is done by the force? Draw the figure here. Draw this figure. Question number 7 tells us a force of simple Newton is applied on an object as shown in the following figure. How much work is done by the force? So I have drawn the figure and I have given you the 5 answers also. Mass of the object is given as 2 kilogram. The initial velocity is 3 meter per second. Final velocity is 7 meter per second. That's all. They have not no any other data is given. Right? So what is the equation needed for this question here? It's a simple question. What is it here? Do you remember this equation? Huh? Work done equals, do you remember this? Increase in kinetic energy. This is what you want to know from this question. There are 5 equations that can be applied to find work done. For 5 different cases, 5 equations are obtained. We have put 5 equations. This is the second one. Increase in kinetic energy means final kinetic energy minus lamai initial kinetic energy. Can you do the rest? Can you do the rest and find the work done? Right. So what is final kinetic energy? Now, final kinetic energy is half mv square. Final kinetic energy, that is half mv square. Initial kinetic energy half m u square. So I can take half m out from a bracket. Half m can be taken out from a bracket. So what are the remaining terms here? V square minus u square. So half m is 2 kilogram, b is 7, u is 3. This 2 and 2 cancelled out. So finally we have 7 square minus 3 square because 2 and 2 cancelled out. 7 square is 49. 3 square is 9. 49 minus 9 is 40. Therefore, work done by this force is 42. So what's the correct answer? Correct answer is 4. Correct answer is 4. That's it. Good job. Question number 8. A bullet is fired with a velocity of 30 meters per second. Question number 8. A bullet is fired with a velocity of 30 meters per second with an angle of 60 degrees to the horizontal. A bullet is fired with a velocity of 30 meters per second with an angle of 60 degrees to the horizontal. The horizontal range is so they ask us to find the horizontal range. Look at the board here. Question number 8. So let's say this is the ground. From the ground, the bullet is fired with a velocity of 30 meters per second. The projected angle is 60 degrees. The question asks us to find the horizontal range. The question asks us to find the horizontal range. Draw this figure here. Actually, in the exam, no need to draw the figure, but let's draw this one. Horizontal range means this R distance. Right. Here, you should use the equation at once. What's the equation here? Horizontal range equation. R square equals 2u square over g sine theta cos theta. Theta is this angle. Theta is this angle. So if you remember this equation, at once you should apply this equation to obtain the answer. This is the MCQ paper. No need to prove these equations. No need to prove. At once apply it and get the answer. That's all. R equals, not R square. R equals 2u square over g sine theta cos theta. 2u square over g sine theta cos theta. 2u square over g sine theta cos theta. So this is 2, u is the projected velocity, g is the gravitation acceleration, that is 10 into the projected angle. The velocity makes an angle of 60 degrees. Sine 60 cos 60. So this is 2 square of 30 is 900 divided by 10. Sine 60 is root 3 over 2. Cos 60 is half. So what are the numbers that can be cancelled out here? This 2 and this 2 can be cancelled out. This 0 and this 0 can be cancelled out. 90 divided by 2. The only remaining number 90 root 3 over 2. So what is 90 divided by 2? 45. Therefore 45 root 3 meter is the horizontal range. So which choice is correct? 45 root 3. Who got this answer? That's it. Question number 9. An object of mass 10 kilogram is moved up along a smooth inclined plane as given below. An object of mass 10 kilogram is moved up along a smooth inclined plane as given below. How much work is done by the force? Let me draw the figure. That's the smooth inclined plane, but it's not a straight line inclined plane. It's curved inclined plane like this. It's a curved inclined plane. This height is given as 3 meters, right? Right. And the object is moved up along this inclined plane. The applied force is F Newton, its magnitude not given. Magnitude of the force is not given. It says only it is F Newton. The velocity increases from 2 meters per second to 6 meters per second. That's the only thing they have. That's the curved inclined plane. It is moved like this by a force of F Newton. The velocity increases from 2 meters per second, u meters per second. Finally, the object is at the height of 3 meters. That's it. The question asks us to find the amount of work done by the force. So what is the equation that you want for this theory? So when the object is moving up along the inclined plane, kinetic energy increases. Because of the increase in height, potential energy increases. So work done by this force is equal to summation of increase in kinetic energy and increase in potential energy. Initial object is on the ground, therefore initial potential energy is 0. So no need to worry about the initial potential energy. So what is the equation here? Right? Work done equals increase. You should remember this equation. Increase in potential energy plus increase in kinetic energy. That's it. So initially there is no potential energy. So increase in potential energy means only the MGH. Only the MGH. Increase in kinetic energy means half mv square minus half m u square. Final kinetic energy minus half initial kinetic energy. Can you do the rest? mass of the object, that must be given, right? Given or not given? (10 kg). Mass of the object is given as 10 kg. M is 10. G is 10. Final height is 3. So actually this is the final potential energy. Final potential energy minus initial potential energy is the increase in potential energy. Initial potential energy is 0. So I did not write it. I have written only the final potential energy. Plus half M can be taken out. Remainder V square minus U square. So 10 into 10, 100 into 3, 300. Plus half mass of the object is 10. B is 6. U is 2. So this is 300. 10 divided by 2 is 5. Square of this 36. Square of 2 is 4. What is 36 minus 4? Am 36 minus 4? 32. So this is 300 plus 5 into 32. So 300 plus 5 times 2, 10. 5 times 3, 15 with the remaining one, 16. So this is 460 joules. 460 joules. Who got this answer? That's good. 460 joules. Question number 10. A block of mass 20 kilogram is moved on a horizontal surface as shown in the figure. What should be the coefficient of kinetic friction? Let me draw the figure here. Question number 10. There is a horizontal surface. An object is an object of mass 20 kilogram. An object of mass 20 kilogram is moved on this surface. So if they ask us to find the coefficient of friction, it means there should be a friction force, right? So let me mark the initial velocity u as 6 meter per second, v as 10 meter per second. If all these data are given, please draw the figure. Draw the figure and mark the given things. and the external force is 100 Newton. The external force is 100 Newton. So there should be a friction force like this. There definitely be a friction force. Otherwise, they can't ask what is the coefficient of kinetic friction. As they ask us to find the coefficient of kinetic friction, there should be a friction force. The time taken for the motion is given as 40 seconds. Draw the figure for the question number 10 quick. The first thing that you want to do is you should find the acceleration. That is the first thing. To find the acceleration, that's the equation. V equals u plus a. Final velocity 10, initial velocity 6. Acceleration time is 40. Take 6 to this side. 10 minus 6 equals a times 40. So 10 minus 6 is 4 equals a times 40. Take 40 to this side. 4 over 40 is the acceleration. Actually, no need to write all the steps like this. Even by looking at the figure, you must be able to tell the acceleration as 1 over 10. Just look at the figure and do the calculations in your mind and tell me the answer as acceleration is 1 over 10. 4 divided by 4 is 1, 10, 40 divided by 4 is 10. So acceleration is 1 over 10 meter per square second. That's it. Complete. Right. So if we know the acceleration, we can find the friction force. There are only two forces. What are the two forces here? The external force and the friction force. Right? There are two horizontal forces. We want to find the resultant force. That's it. Or we can find the friction force at once, no need to find resultant force. We can find the friction force at once. Along the horizontal direction, I can apply F equals M. Look at what stop right here. There are two horizontal forces, the external force and the friction force. External force is into right hand side, friction force is into left hand side. Therefore, the force, the total force into the right hand side, the resultant force into the right hand side is FEH minus FR. Right? Force into right hand side minus force into left hand side is the total force or the resultant force. Mass is 10. Acceleration is 1 over 2. Can you do the rest and find FR? 1 over 10 means 0.1 if you want. Find the friction force Fr. Right. The external force is given as 100. I want to find the friction force. This is 10 and 10 cancelled out. Therefore, the acceleration is only 1. Am I right here? Is mass 20? Sorry, mass is 20 kilograms. Sorry. Mass is 20 kilograms. So 20 divided by 10 is 2. Mass is 20 kilograms. I made a mistake. 20 kilograms. So 100 plus 2 comes this side as minus 2. Minus FR goes to the other side as plus FR. What is 100 minus 2 here? 90. So the friction force is 98 Newton. So there are some calculations in this question. Who got this answer? Excellent. Now I should put this figure separately. Listen there. If I consider this figure, what are the forces acting on it? Horizontal external force, horizontal friction force, gravitation attraction force. What is the other force there? The normal reaction force given by the surface. So once I mark all the forces acting on the object like this diagram, this figure is said to be the free body diagram. What's the name there? Free body diagram. Sometimes said to be free force diagram. Right. So when I explain an MCQ, I give all the details. Even student who has not learned this theory should be able to understand after this discussion, because I give all the details, everything. So according to this diagram, the upward force should be equal to the downward force. Upward force R, downward force mg. So R should be equal to mg. mg is 20, g is 10. Therefore, the normal reaction force acting on this object is 200 Newton. Something. The normal reaction force acting on this object is 200 Newton. Right. How do you find the coefficient of friction? Coefficient of friction. Friction force, kinetic friction force is equal to lamai. Friction force is equal to mu r. Friction force is, we have found it as 98. This is mu. Normal reaction force is 200. Can you do the rest and find mu dear? Normal reaction force was found as 200. Find mu. No units, right? No units, no dimensions. Because all the units and dimensions are cancelled out, right? Because 98 Newton, 200 Newton. So Newton cancelled out. Only mu will be there. Mu has a numerical value. So number will be there. So if we take 200 to this side, 98 divided by 200 equals mu. Therefore, mu equals, what is 98 divided by 2 dear? 9 divided by 2 is 4. 1 remaining, 18 divided by 2 is 9. 4, 9. What is 200 divided by 2? 98 divided by 2. 49. 200 divided by 2 is 100. 49 divided by 100. 0.49. So mu equals 0.49. No units. No units. That's it. Who got this answer?